A very good morning, student. This is the lecture of object oriented programming using C++. So in the previous lecture we already started our first unit, principles of object oriented programming. Also we have completed our first subpoint, that is procedure oriented programming versus object oriented programming. In this first subpoint we have seen concept of procedure oriented programming, that is POP, concept of object oriented programming, that is OOP, and the difference between object oriented programming and procedure oriented programming. Now in this lecture we will start the second subpoint, and our second subpoint is basic concepts of object oriented programming. First we will see the learning outcome. At the end of this lecture you will be able to understand and explain basic concept of object oriented programming, different languages present in object oriented language, and application of object oriented programming. The content of this lecture, this is the second subpoint, basic concept of object oriented programming, object oriented languages, and application of object oriented programming. As we know that in the procedure oriented programming the main focus on the procedures, and in object oriented programming the focus on the data. So in the object oriented programming everything is in the form of object and classes. Let us start our first point, basic concept of object oriented programming. See here, object oriented programming is the most recent concept among programming paradigms, and it provides a way of modularizing programs by creating partitioned memory area for both the variables, that is data, and the functions, and it can be used as a template for creating copies of such modules on demand. To understand the concept of OOP, it is necessary to understand some of the concepts used extensively in the object oriented programming. Now these are the basic concept of object oriented programming. Also these are the features which is not included in the procedure oriented programming. The first is objects, classes, data abstraction and encapsulation, inheritance, polymorphism, dynamic binding, message passing. These are the basic concept of object oriented programming. Now we will discuss these concepts in this today's lecture. As we know, in the procedure oriented programming the large program is divided into number of small units known as the function, but in the object oriented programming the program is divided into the units called as a object. So objects are the basic runtime entities, and they may represent like person, place, bank account, university, building, table, data, or any item that the program has to handle. An object is an instance of a class, means after creating class we can create object of that class, and that class has data as well as function which is transferred or work as a blueprint for the object. An object consists of two characteristics. Okay, these are the two characteristics, namely data or state or attribute and behavior or operation or function. So object consists of two characteristics like state and behavior. So what is state? The state of an object is one of the conditions that the object can exist in, and it is represented by its characteristics. Like here, object is a student and its attribute or state is the name of student, date of birth or mark. And the function means behavior of that object. So total, average, display, these are the behavior of the object, that is a function of the object. When a program is executed, the objects interact by sending message to one another. Means after creating one class, we can create number of objects, and if that object wants to communicate with each other, they can communicate with each other by using functions. That is called as a member function. Each object contains data as well as code. Code means nothing but the function to manipulate the data. Means this function is used to perform the operation on this data. So object can interact without having to know details of each other's data or code. Suppose there are two objects like object A and object B, and suppose if the object A wants to access the data of object B, so they interact with their member function without having to know details of the object of B. So this is a representation of object. Here the attributes or data of the object is represented as a variables, and code of the object is represented by the functions. Now we will see the next point, that is classes. So the entire set of data and code of an object can be made a user defined data type with the help of class. Means what? Class is the user defined data type and it contains the data as well as code. Each object is associated with the data of type class with which they are created. Classes are user defined that types and behave like the built-in types of a programming language. A class provides a template or plan or blueprint to create object of particular type. To create an object of a particular class, we need to specify the data members and member function of the particular class. So suppose if you want to declare class, it is same like the declaring variable in the C language. If you want to declare a variable, first we have to write the data type and after that we write the variable name. Here same, if car has been defined as a class, then the statement of declaring class is the car and object is a BMW. Like integer, number, integer is a data type and number is the variable. Here car is a class and BMW is a object. It will create an object BMW belonging to the car class. So car is a class. It has some attributes related to cars like model, brand, speed, mileage, etc. And BMW is the one of the object. After declaring a car, we can create number of objects like BMW, Volvo, Toyota, etc. So these are the different types of object which is derived from this car class. For the clear understanding, we will see one example. See here, class and objects. So this is the basic car prototype. This is the basic car prototype having the 4 wheels, okay, brake, accelerators, color. These are the different property. This can be anything like BMW, Audi, etc. Here objects, BMW, Audi, Ferrari. The basic characteristic of these objects are same. So class is a blueprint. You can build any type of car from this basic model. This is the basic model. By using this we can create or we can develop any type of object like BMW, Audi and Ferrari. Now next point is a data abstraction and encapsulation. First we will see the data abstraction. Abstraction refers to the act of representing essential features without including the background details or explanation. In object-oriented programming, each object will have external interfaces through which it can be used. So there is no need to look into its inner details. There is no need to look into the inner details. So the user needs to know the external interfaces only to make use of an object. Okay. The internal details of the object are hidden, which makes them abstract. And suppose, what is data abstraction means? If any object wants to access the object of another class or data of another object, there is no need to know the inner details of that program. Because of this data abstraction, the object-oriented programming languages are more secure. Classes use the concept of abstraction and are defined as a list of abstract attributes such as size, weight and cost, and function operate on these attributes. Many different abstractions of the same things are possible depending on the purpose for which they are made. So, in a simple words, we can say that abstraction as the act of representing essential features, that is important features, without including the background details or explanation or the complexity. Data abstraction is the process of defining a data type, often called an abstract data type, that is ADT. We will see it into the next points. Now, data encapsulation. It is the most striking feature of the object-oriented programming. Encapsulation is the technique of binding the data and the function in the single unit called a class. The wrapping up of data and function into a single unit is known as the encapsulation. So the data is not accessible to the outside world, and only those functions which are wrapped in the class can access it. Encapsulation is the way of implement data abstraction in OOP. A well-encapsulated object acts as a black box for other parts of the program. That is, it provides services to the external function, but that external function do not need to know its internal details. So what is encapsulation? Encapsulation means wrapping up of data and function into a single unit. So we will see the previous slide. Here object student has the data as well as function, and encapsulating these two into the single unit known as the class. Now the next point, that is inheritance. The ability of object of one class to acquire the properties of object of another class is known as the inheritance. In object-oriented programming, the concept of inheritance provides the idea of reusability. Means inheritance is the process by which objects of one class acquire the properties of the another class, object of the another class. The existing class is known as the base class, and the new class derived from the existing class is known as the derived class. This means that we can add additional feature to an existing class without modifying it. This is possible by deriving a new class from the existing one. The new class will have the combined feature of the both the classes. Here we will see an example, that is bird is a class. It has attribute like feathers, lay eggs, etc. Also it has some functions like flying. Okay, so these are the two different classes, that is flying bird and non-flying bird. Now this flying bird is derived from the base class, that is bird. So this is the new class which is known as the derived class, and this is the existing class known as the base class. Flying bird class is derived from the bird class. So now the attributes of the bird class, that is feathers and legs, are already present in the flying bird. Also flying bird class can add its own attributes, same like here. Non-flying bird, this is also derived class and it is derived from the bird class. So this class also have these attributes, also it can add its own attributes. Now in the non-flying birds, penguin and kiwi, these are the derived class which is derived from this already existing class. So penguin is a non-flying bird, kiwi is also non-flying bird. So they both has the same properties as the non-flying bird. Also they can add its own properties. So this is the inheritance. In inheritance it has 5 types, like single inheritance, multi-level inheritance, multiple inheritance, hierarchical inheritance and hybrid inheritance. This is the one type of hierarchical inheritance. So what is the advantage of inheritance? Inheritance permits code reusability. Once a base class is written, it need not to be changed in order to adapt to work in different situation or condition. Means once we declare base class, we need not repeat once again in the derived class. Reusing existing code saves time. So it already had some code, so it saves time to write same code in the derived class. Okay, we know that it has the 5 types. We will see what are the types of inheritance. First one is a single inheritance. A derived class with only one base class is called single inheritance. Means suppose we declare one class and from that base class we have derived a single class, then it is known as a single inheritance. The next is a multiple inheritance. A derived class with more than one base class is called a multiple inheritance. Means here suppose there are 2 base class and we have derived one new class from that both base classes. Next one is a hierarchical inheritance. Here is the example of hierarchical inheritance. If one base class is inherited by more than one derived class, then it is called as a hierarchical inheritance. Here bird is a base class and it is derived into two derived class, that is flying bird and non-flying bird. So it is a hierarchical inheritance. Next is a multi-level inheritance. The mechanism of deriving a class from another derived class is known as multi-level inheritance. Means suppose here kiwi is the derived class which is derived from the non-flying bird class, and it is also derived class from the bird class. So this is the multi-level. Deriving a class from another derived class is known as the multi-level inheritance. And last one is a hybrid inheritance. Once class is inherited by many derived classes which are again base class for the other derived class. This is form of inheritance is called as a hybrid inheritance. We will see this point deeply in the third unit. Now next is a polymorphism. So polymorphism means the ability to take more than one form. So polymorphism is a Greek word which is combination of poly means many and morph means form. An operation may exhibit different instance. The behavior depends upon the type of data used in the operation. A language feature that allows a function or operator to be given more than one definition. The types of the arguments with which the function or operator is called determines which definition will be used. Overloading may be operator overloading or function overloading. This polymorphism has two types, that is runtime polymorphism and compile time polymorphism. Here one example of the polymorphism, that is a function polymorphism or function overloading. Here we see that shape is a class and it has one function, that is draw. From that shape class here three classes are derived. Three objects are created, that is circle, box and triangle. But it has same function name, that is draw circle, draw box and draw triangle. The function name is the same, that is a draw, but it behaves differently. To draw the circle we need the radius of the circle. For draw the box we need the length and breadth, and to draw the triangle we need the base and angles. So this is a polymorphism, same name but behavior is different. Next is a dynamic binding. Dynamic binding means binding at the time of running or executing. Binding refers to the linking of a procedure call to the code to be executed in response to the call. Means suppose we call any function, then the linking of that procedure call after calling that function is known as the binding. Dynamic binding means that the code associated with a given procedure call is not known until the time of the call at the runtime. It is associated with polymorphism and inheritance. A function call associated with a polymorphic reference depends on the dynamic type of that reference. Dynamic binding is the process of linking a function call to the actual code of the function at the runtime. That is dynamic binding. The actual code to be executed is not known to the compiler until runtime. Means after executing the program, it will know which module or which function going to be executed. Last concept is a message passing. An object-oriented program consists of a set of objects that communicate with each other. The process of programming in an object-oriented language involves the following basic steps, that is creating classes that define object and their behavior, creating objects from class definition, and establishing communication among objects. Objects communicate with one another by sending and receiving information. message in object-oriented programming comprises the name of the object, name of the function, and information to be sent to the object in the form of argument to the function. A message for an object is a request for execution of a procedure and therefore will invoke a function procedure in the receiving object that generates the desired result. Message passing involves specifying the name of object, the name of function, and the information to be sent. Means we can pass the information by using the function to the object. So this is a message passing concept. So we have seen the basic concept of object-oriented programming, and these are object, classes, data abstraction and encapsulation, inheritance, polymorphism, dynamic binding and message passing. Now we will see the remaining points in the next lecture.